Fine. So before I go into the detailed methods how to use these instructions, I will quickly give you an idea about the addressing. You might have done some addressing while you are doing your lab. So let's discuss that part as well. So we will be normally solving these kind of problems with the PLC. And if you see here, because you have not gone through an automation course, but let me quickly explain you how we will build a circuit and what kind of controls we will be implementing through PLC programming. So in this case, if you see here, we have actuator over here. I'm sure some of you may be familiar with this. So this is basically the actuator over here. So you have a piston inside the actuator and you have a rod coming out of this actuator. So we have two actuators. No, it's basically the same diagram drawn differently. The difference is mainly in the direction control valve in this case. So if you see here, this is a double acting cylinder or double acting actuator, and which is like a cylindrical body with a piston and a rod inside it. So once you make the fluid entering into this side of the cylinder, your rod will be moving forward. And whenever you want to retract it, you will be making the fluid entering from this side and it will be leaving from this side. So that is how with the control of the direction of the flow, you will be either extending the cylinder or you will be retracting the cylinder. Now how we will be reversing the flow direction? For that we normally use these direction control valve. We call DCVs. It's a direction control valve. Now these are the solenoid operated direction control valve. So in that case, if you energize this solenoid, so if you see here, we have two solenoids, one Y1 and one Y2. So these are the symbols for the solenoid on this valve. So if you energize one Y1 and then this part of the valve get activated and the flow will be basically entering from this side and coming out from this side. So this will make the cylinder moving forward. So if I energize one Y1, I will be making the cylinder movement forward. And if I will energize one Y2, I will be making cylinder retracting in this direction. So that is the way with the help of a direction control valve, I will be able to control the direction of the movement of the cylinder. So that is the uh, way we normally implement for the pneumatics as well as the hydraulic cylinders in this case. Right? Yeah. So now same cylinder, if you see here in the second circuit, instead of using two solenoids, we have used two solenoids, one Y1 and one Y2 in this valve. In case of a second cylinder configuration, we are using only one solenoid here, that is one Y1, but we have used a spring on the other side. It means that by default, this position is maintained by the spring. So you need not to energize anything on the other side. So by default, if you see this position, it means that your incoming line is now, you have to just follow the arrow. So this it means that making the fluid entering from this side and the second side, the fluid is coming out and going back to the reservoir. So that way the cylinder will be in a retracted position by default with the help of this spring configuration on the direction control valve. Only when you energize this one Y1, once I make the current flow into this solenoid, the cylinder will move forward. And the moment I make the current off into this solenoid, the cylinder will go back to the original position with the help of this spring return mechanism here. So your direction control valve is having a one solenoid and on one side it's in a spring offset position. So that is how these are the two different configurations. Now let's quickly understand what is the pros and cons of these two designs here. If you see, these are the two positions of the valve. This is one position, this is the another position of the valve. And if you energize this, the valve position, this will be maintained. It will not go back to the second position. So by default, if you energize this, the spool, normally these are the spool type of valve, the spool inside the valve will remain in this position. If you have to change the position, you have to energize the second valve, solenoid actually in this case. So if you energize the second solenoid, then the position will change to this. It means that if I am not if I'm not changing the position of the spool intentionally, it will remain in that position, and that is what is known as latching actually. It's a very important concept that we need to understand. So the state of the spool or state of the wall will remain as it is. And most of the mechanical switches, if you remember, or you might have seen that there are two type of buttons. One is the push button. When you say push button and whenever you say switch, there's a two different interpretation of the functions here. If you say the push button, if I press the push button, the connection will be on, and if I release the push button, the connection will be off. So you most of the time when there's a doorbell kind of switches, then we have these push buttons. When it comes to the control switches, these are like your light switches in the room. So if you just press on one side, it is mechanically detented. It means that if once you make it on, it will remain on. And if you make it off, it will be off. So those are the switches. So if you see in this configuration, this is now let's try to get answer from Anuj Seni.
Yes, sir.
Anuj, are you there?
Yes, sir.
So I have mentioned the push button and the control switch configurations. So
Yes,
out
sir.
of these, so if I just say this is your A and this is your B, which configuration is like a push button?
Sir, the second one is the push button.
Correct, correct. You're right. So in that case, till you keep the 1Y1 energized, the wall will be on. And the moment you release the current from 1Y1, the wall will go off. So this is almost like a push button. Till you are keeping this push button press, circuit is on. The moment you remove the mechanical force from the push button, the circuit will be off. And the configuration A is like a control switch that once you make it on here like this, so once you energize this, the configuration of the wall will remain as it is. It will not change on its own till you make the another configuration on, that is you energize the solenoid 1/2. So this is a configuration like a control switch. So if I just want to write down, this is like control switch and this is like a push button. So I'm just giving you analogy. This is not exactly like this. So because you have not understood this pneumatics and electromagnetic circuits earlier, so I'm just giving you an understanding that if you see this configuration with the two solenoids on the wall, it will be like a control switch. That if you energize 1/1, the wall will be energized and the cylinder will be moving forward. Now, if you see, if I make the current on in Y1 and before the cylinder reaches to the forward end position, if I remove the current from 1/1, the cylinder will retract immediately. That is the point that we need to understand. At any moment, any point of time, if you make the current off from 1/1, the cylinder will go back. So I'm sure that you understood this basic functionality of the control of the pneumatic cylinders with the help of direction control valve and with the help of energization the two solenoids. So one solenoid or two solenoids. So they are known as electrically actuated direction control valve or the solenoid actuated direction control valve. Is this clear? I hope all of you understood this. Anyone, if you have any doubt, please let me know because you may not find this content as it is available in any other book as such. So if you are not understanding anything, I can discuss and explain in the class once again. If this is well understood, then let's go ahead for the problem that we will be attempting now. So what we have to do now, if you see the problem statement says draw the PLC connection diagram. So the way you're supposed to attempt is like this. So you have to draw the PLC connection diagram and you have to draw the ladder logic over here. So let me just explain you how to do that. So I will just add a page over here and then explain it. Yeah. So let's try to understand if I have to draw a PLC connection diagram. So now last time we did that exercise, we have to understand what are the inputs and outputs before we start making the PLC connection diagram. So what I have to do whenever we have to attempt this kind of a problem, I have to first draw a PLC. So the way I am supposed to draw the PLC is like that. I have to draw a square box, a rectangular box. So I will say that this is my PLC, and then I will be having input terminals on the left hand side, and I will have output terminals on the right hand side. So I'm symbolically representing the PLC like this. So you have inputs and you have outputs over here. And your center part is PLC. When I say PLCs is everything included, but then mainly I'm just referring to the CPU inside here. So that way, once you draw the PLC like this, now now, as I was explaining, whenever you have input-output modules, you will be having screw terminals. So like this, you will be having a physical screw terminals to which you will be connecting your devices here. So same way, I will be having a screw terminal on output side as well. So when I say connection diagram, we have to symbolically represent how the physical devices will be connected to the PLC. So before we come to this diagram, now we'll go back to our problem statement and try to understand how many inputs and outputs I would like to interface for controlling this. So let's take an example of the first circuit diagram here. So this is your pneumatic circuit. Now we will be drawing the PLC connection diagram for this. Now, before we go forward, we'll also be including some sensors over here. So normally, whenever we have these kind of pneumatic circuits or hydraulic circuits, the sensing requirement is to sense the end position of the actuator. So when I say end position of the actuator, it means that I would like to have a sensor, one sensor at this position and one sensor at this position. So let's call that sensor 1B1. These are the proximity sensors, or maybe similar to the reed switches that you have seen in the last class. So we have two sensors. We placed two sensors over here, 1B1 and 1B2. So once your piston is at this position, I will be getting a 24-volt signal here. If the cylinder will be reaching to the forward end position, I will be getting a signal from 1B2. So these sensors are giving me 24-volt or 0-volt. So if there is a proximity of the piston to these sensors, I will be getting 24-volt. So this will be representing logic true. This is representing logic false. So the moment the piston moves away from the proximity switch, the value that I will be getting will be 0-volt. And the moment it comes in close proximity with 1B1 and 1B2, I will be getting plus 24-volt. So that is the way we need to sense the end position of the piston inside the actuator. And then we will be controlling the movement of the cylinder with the help of 1Y1 and 1Y2. These are the two solenoids which we need to energize. So when I say solenoid, it's just an electromagnet which will be pulling the spool towards it. That is the way you can understand. So we need to provide plus 24-volt here so that it will be energized, and then it will actuate that particular position of the valve and make the cylinder moving forward or the backward. So with this understanding, let me just ask uh, Nikhil Kumar.
Yes, sir.
So Nikhil, how many digital inputs you have here? Because we need to connect these digital inputs to the PLC here. So I need to know, and we are not talking about analog right now. Let's focus on the digital only. So we have to connect the digital inputs or interfaces to this PLC. So I need to know which are the devices I will be connecting to the digital input side of the PLC.
Sir, sir, I guess two, one for 1B1 and one for 1B2.
Correct, correct. So your guess is correct. So be confident that whatever you are saying is right. It means
Okay.
that we have two inputs, 1B1 and 1B2, because I would like to sense the two end position of the actuator. So I will be connecting these two inputs to the two sensors to the input side of the PLC. Same way, let's try to understand Sachin Narwal. Which are the outputs that you will be connecting?
So the outputs will be connected to 1Y1 and 1Y2.
1Y2, correct. So we understood now that we need two digital inputs. So we have seen that these are the DIs that we have, that is two numbers, and we understand these are the digital output, which are also two numbers. So for attempting this circuit diagram, if I have to physically connect this circuit diagram with the PLC, I have to connect these two sensors to digital inputs and two solenoids to the digital output. So with this understanding, now let's come to this figure. Now what I am supposed to do, I have to connect the input. So let me draw the symbol for the proximity switch, which you have not learned earlier, but now you can understand and you can note down also. So proximity, we normally draw this rhombus with a double lines like this. And whenever we have these proximity switches, they are electronic proximity switches. So I will cover up briefly into the sensors class. I will take subsequently to give you an idea on that. But till then, we'll just try to understand. So these proximity switches are electronic switches. They are inductive proximity switches, capacitive proximity switches, or optical proximity. So we have plus 24 volt connection because we have to provide the power supply to these switches. Then we will be having a ground over here. So you will be connecting the other side of, so we have to give a power to these switches. So this is the 1B1. So if you have to use these proximity switches, I have to provide plus 24 volt. I have to connect it to the ground. And then I will be having output coming out of this. So there's an output coming out of this. So in that case, whenever the object is in close proximity of this, I will be getting plus 24 volt as an output from this device. And it will be 0 volt when there is no object in proximity of this. So this is the output terminal, so that you will be getting either of these two outputs from this. So when I say output, means output of the sensor. Please understand, don't get confused with the output of the PLC. Output of the sensor will be going into the input of the PLC. That is how the PLC will be able to read it. Fine. So I hope you understand this symbol for the proximity over here. And let's try to make use of it and draw it. So what we have to do, we have to draw two such connections or two such proximity switches connected to the input side of the PLC. So let me just draw that. So what we have to draw, we have to draw a proximity switch like this. We have to draw, you please understand this, and you can also do practice if you have a notebook in front of you, so that you can understand. So I have to connect this to the plus 24 volt supply. I have to connect. So this is the way you have to draw the connection diagram. Please note that. And the other side I will be connecting to the ground. Now this output of this proximity switch, I will be interfacing with the input of the PLC. So this is what I have done now. So I've connected one such switch, that is 1B1. Same way I have to connect another proximity switch here. So I will just, what I will do, I will just copy this. Yeah, so this is the way I have connected two proximity switches, 1B1 and 1B2, to any of the two terminals. So I am not specific that I have to connect to these two successive terminals only. I can connect these two inputs anywhere onto the PLC input side. So we'll come to the addressing later on when we discuss that, how we will identify that where the proximity switch is connected. So till now, we have to just understand this part. So same way, now we have to connect the solenoids on the output side. So if you see, the solenoids are the devices which are electromagnets, as I was explaining. So what we can do, we can just draw the symbol for the solenoid. Now solenoid is coil, and if you have to give a 24 volt, it will get energized. That is the way we have to draw this. So if you can see that again, in this case, I will be connecting one terminal to the ground of this solenoid and another terminal I will be connecting to the PLC output. So that if the plus 24 volt is given over here, this will be on. And if I will not give plus 24 volt, it means there's a 0 volt over here, then this will be off. So that way I will be able to control on and off of this solenoid from the output terminal of the PLC. So let's try to draw this as well. So with this understanding, now we have two solenoids over here. So what we will do, we will connect these two devices like this. So we'll connect the second device, we'll connect like this. And this one terminal we had made ground, that's a 0 volt. And plus 24 volt is coming from the PLC output in this case. So if you can see here, this is 1Y1 and this is 1Y2. So these are the two outputs that we have interfaced, and we have interfaced two inputs to this PLC. So this completes your connection diagram. Without knowing the connection diagram, you can't interpret the program, or you can't interpret the ladder logic, because we will be writing the ladder logic based on the program that based on the connections that we had made over here. Fine. So once you complete the connections over here, this connection diagram is complete. Now our next task is basically to draw the logic for this. So now let's come to the the pneumatic circuit diagram. Now we have to implement a functionality here that once, so there's no push button specified here, so that part we forgot. So let us add few push buttons also, so that I will be having two push buttons to control. Otherwise, how you will control the actuator movement? Actually, there should be some user inputs. 1B1, 1B2 is just to sense the end position of the actuator, but we have not given any options for an operator to control this movement. So I will be using S1 as one push button and then S2 as another push button. So these are the two push buttons which I have to again interface with the PLC connection diagram, and then I will be implementing a functionality. When S1 is pressed, your cylinder should extend, and when the S2 is pressed, the cylinder should come back. So that is the functionality we will be trying to implement. It's a very basic functionality in case of a electropneumatic circuits. So let's go and draw the two push buttons also, because these are the inputs required. So what I will do, I will connect the push button like this. This is your S1. Let's place this another one here itself. This is your S2. Anyone let me understand what shall I connect on this side of the push button? So one side I have connected to the PLC inputs. What shall I connect on this side?
Sir, this is power supply 24 volt.
Yes, you're right. So I have to connect plus 24 volts. So what I will do, I will just make connections like this. So I've connected plus 24 volt on these two terminals. So now in that case, if you're not pressing push buttons, PLC will read it 0. And the moment you press the push button, plus 24 will be available to this terminal and it will be reading as 1. Right? So then now we have, so this way we now end up in having 4 DIs, 2 for the push button, 2 for the proximity switches, and we have 2 DOs here. Good. So your connection diagram is over. Let's try to write the logic part over here. Now, as I was mentioning, our logic is very straightforward here. What we want that whenever S1 is pressed, S1 is on, I want cylinder extend. And when I want the push button S2 on, cylinder retract. But the condition will remain same. One more condition we would like to implement, that whenever you are pressing S2, S1 should be released. We should not keep the S1 also on and S2 should also be on, then it will not work. So what we want, once you press S1, your cylinder will extend, then you have to just momentarily press the push button and release it. Same with the way normally you operate the push button functionalities, you press it and release it. So S1, if you press S1 and release it, it will extend. If you press S2 and release it, it will retract. So I'll just give you 1 or 2 minutes. Please write the ladder logic for this. Please write the ladder logic for this, then we'll discuss. So just let's take another 30 seconds or 1 minute so that you will complete this. Everyone please do that, and then I will share the solution and we'll discuss it accordingly so that I will understand if you are facing any challenge in attempting it. Because these are the very basic and straightforward logic. And once you understand it, then only we'll discuss the next part of the logic. So please do that. Those who complete can raise your hand so that I can see that. So if you are facing any difficulty in understanding this part as well, please let me know. I will explain that functionality again. Anything that you are not understanding or you are not sure how to do it. Anyone able to do this? Because you have done similar thing in the last class as well, lab class basically. Okay, good. So Swabhiman has done this. Fine. So I think whatever you are done, that's fine. Let's discuss on this part. So we'll discuss in the class only. Again, I will just ask what to write and how to do that. So we will be now drawing the PLC logic here. So for drawing the logic, what I have to do, I have to just draw two vertical straight lines. As we all understand, these are the ways we are supposed to write the PLC ladder logic here, like this. So we will start with the rung 0 here, and then we'll go on rung 1, rung 2. So in the first rung 0, what should I draw actually? So let me ask Sahil Gailawat.
Yes, sir.
Sahil, what shall I draw the first logic? So my requirement is that whenever S1 is pressed or S1 is on, my cylinder should extend.
Sir, we can take the entry sensor for examine if closed for S1.
Correct, correct. So first instruction that we have to draw is examine if closed. So this is the symbol that we have learned last time for the XIC instruction. You're right. So this is the first XIC instruction that I have to draw here. And examine if closed. It means I will be checking whether the S1 is pressed or not. And then in response to that, what I have to do, I have to energize a solenoid. So I have to energize solenoid 1 by 1 to make the cylinder extend. That is what I can understand from my pneumatic circuit diagram. So what I have to do now, I have to connect another instruction over here. And this instruction is your OTE instruction. Is this clear?
Yes, sir.
Yeah. So what we have done, we have used two instructions over here, one input instruction and one output instruction. And when I use this XIC, it means that it will be checking the state of push button. XIC will read whether it is closed, because by default this is open. So examine if closed. If it is closed, energize the solenoid. So what we will do, we'll just use S1 and we'll mark 1 by 1 here. Is that right? Anything else we have to add here? for the first instruction, first rung itself? Anyone? Because we are missing something because there are two proximity switches we have not used. Yeah, Paras?
सर एड्रेस नहीं लिखना इसमें डिजिटल
No, address we will discuss subsequently. Right now we are just trying to understand the logic, because then I will discuss the address later on. But I'm just
Sir.
looking at, I have to sense something also, which is missing right now.
Sir, when the piston is close to 1B1, we have to on
Correct.
this
So
S1.
what? Yeah, you're right. So what we have to check basically, or what I have to just verify, that the cylinder should be at the retracted position in this condition. So before I press S1, I would like to ensure that that the cylinder should be at the retracted position. So my logic will appear like this: when the cylinder is the retracted position and S1 is on, then extend the cylinder. This is the way I would like to implement the logic. So now what change I should do here in the circuit diagram?
We should add 1B1 in series with S1.
Correct, correct. So what we have to do, because we are checking the end condition, please note that what we want to check, we are putting an end condition here, that both the conditions should be true. That cylinder should be at the retracted position and S1 is pressed, and then operator press S1. Then only cylinder should extend. To implement this and what I have to do, I have to add one more XIC instruction over here. So what I will do, I will add one more XIC instruction. And this XIC instruction is coming from the 1B1. The input that I would like to read is 1B1. Now this will implement the condition, if you can see here, when S1 is true and 1B1 is also true, then your output will be true, because we place them in series. So this is implementing an AND condition. Your first logic is done now. I'm sure all of you have now understood this part. You have already done in the lab also. If you have understood this first rung of the instruction, you understood 50% of the PLC programming. Anybody who has not understood this first rung, how we have written that, and if there's any issue, we'll discuss right now. Is this clear to everyone? Good. So I understand that all of you agree that you understood this part. Let's go to the second logic that we have to implement. Now, Yatin will let us know what should I draw in the second rung. That is the rung 1. Now my requirement. So first we will write down this kind of statement. That is also fine. Before you build the logic, you can just write down, and later on we'll see that we have to draw the table, and then normally we'll draw the table what condition is the prerequisite for executing that particular rung. So we will define the inputs here. So what is the input for the second rung? What should I be checking? So second functionality is that when S2 is pressed, your cylinder should retract. So Yatin, let us know what should I draw now?
So according to me, first should be checked whether the switch 1 is off or not. So according to that, XIO instruction should be there.
No, that we will not be checking right now. What I will suggest that we will be just keeping as an instruction that you have to release S1 before you energize S2. So that instruction will be good enough. Let's not make it more complex right now. So we are assuming that S1 is released actually, and now I would like to retract the cylinder.
That's then for XIC instruction for S2, sir.
Yeah, so I will use another XIC instruction here, and that is for S2. And then I will be energizing the second solenoid, and that instruction is OTE, and this is the second solenoid. You can add instruction to verify that the cylinder should reach the extended position, then only you will be pressing S2. That part also you can add here. The way we have checked the 1B1 in this case. So same way you can add 1B2 also. So once your cylinder is fully extended and you press S2, then it will go back. So that is possible. So you have already done this part of the logic here for the first circuit diagram here. This is the way you will be able to control the motion of the cylinder forward and backward. with the help of two push buttons that are being used over here. Now let us come to the second circuit diagram here, which is further interesting. Now you have only one solenoid and one spring on this side. Now, if I have to implement the same functionality for the second circuit diagram, is there any change on the electrical circuit diagram, and is there any change on the ladder logic? So you have to tell me that part. So just a minute. So let me just copy this if I can. Yeah, so what we have done, so we have now the same circuit diagram. Let's try to make the changes for the second pneumatic circuit, which is having only one solenoid and one spring in that case. So please let me know what changes we have to make here.
Sir, we can use output latch.
Yeah, so first let us discuss the changes that we need to make on the electrical circuit diagram or the connection diagram.
Sir, the second output we can remove.
Yes, so this is not there. So we are only having one solenoid here. We still require two push buttons. Yes.
Okay.
And we will be having two proximity switches to sense that. So that remains fine. So we'll just use one output solenoid. And now you are seeing some changes to on the ladder logic. What should be that change?
Sir, we can use output latch.
Output latch. So that's what the three instructions we discussed. So we discussed the instruction OTE, which is then output energize, and we have used this instruction in the first circuit diagram or first ladder logic. And for the second one, we will be using these two instructions, output latch and output unlatch. Now, what is the situation for the OTE? Whenever the input is true here, this will be true. The moment this is false, this will also be false. That is how the OTE instructions work. Now, when it comes to the output latch, whenever this is true, this output will be on. Fine. This is also true. Now, if this will go off, this will still remain true because you latched it. So latching means that the moment if you see that you are using a remote of a television and once you press on, you need not to keep it pressed on. Once you press it, the system will remember that state, that the circuit will remain on or your TV will remain on. Same way, the moment you make it on here, you will provide a true here. This latch will be storing that information and it will keep it on always, even if this is false. So once you make the output on with the OTL instruction, that it means that I have made the output latch. There's only the possibility that I can make this output off is through the unlatch instruction. And this unlatch instruction is the second instruction, which is OTU. Where you have an alphabet U written in that. So if you see the symbols are almost same, this is output energize. If I put an L here, then it is output latch. If I put U here, then it's an output unlatch. That's how the three symbols will be. So I can only make the output on with the output latch, and I can make output off only with the output unlatch in this case. In case of an output latch and unlatch, you have to give true in both the cases. If I give true over here, it will latch it. It means it will make it on. If I give true over here, it will unlatch it. Please note that this true. Making this off or this false will not help. In case of output energize, this is like this. This is true. This is true. This is false. This is false. This is how the output energize work. But in case of an OTL, once you make this true, this output will remain true. And once this goes false, this will still remain true. To make the output false, I have to make the second statement true. That is the unlatch. then only it will go off. So now with this understanding, let's try to draw the ladder logic for the second requirement. Now in the second requirement, that once you press push button S1, see, the moment you are pressing the S1, your 1Y1 will be on. But I would like to keep 1Y1 on irrespective of the state of S1. So in that case, what I will be doing, as you understand, we will be using an OTL instruction. So what we will do, we'll remove this instruction here and we will use, let's put in that OTL and then we'll write L. So output latch instruction. So now what will happen once you press S1 and 1V1 is also true. Now once these conditions are true, this is true, this is true, this will be true. Now, the moment you release the push button S1, this will go false. So they are in series. So this logic is false now, but your output still remain on because you have latched internally in the memory. Fine. Now it means that it will keep the solenoid on. It will keep this 1Y1 on so that the cylinder will keep extending even if you remove the S1. If you will not be using a latch instruction, then your 1Y1 will go immediately false the moment you release the push button. Fine. And then once this is extended fully, and if I have to retract, then I have to just stop the current in 1Y1. It means that I have to unlatch 1Y1. Then because of the spring force, it will go back. So to implement that, what we have to do, in this case, I have to just replace the second instruction. So please note that because we have only one solenoid, so the second instruction will also be addressing the same input. It's not, sorry, same output. It's not different output. So it's again 1Y1 only. Only difference comes that I will be using unlatch instruction here. So based on the type of wall, based on the devices that you are connecting or interfacing with the PLC, your logic should also be changing. So if I am using a double solenoid, we call it a double solenoid direction control valve. The first is basically because you have two solenoids here. It's a double solenoid direction control valve, and this is in a single solenoid or spring offset DCV. So I'm still controlling the same double acting cylinder in both the cases. But in first functionality, I will be implementing the latching, I should say, in the valve itself. So it means that once you energize 1Y1 for a moment, there is no spring, so the position will remain same. And in the second case, I will be energizing 1Y1 and then storing the state of this on in the latch instruction. And that is how the OTL and OTU will be used to control the second cylinder. I hope with this example, you at least get a basic understanding, basic sense how we are normally building the logic. So let's do one more exercise quickly. And what I want now, yeah, any doubt here?
Sir, why would we need two switches in this case?
No, because see, releasing S1 will not make the cylinder off. See, it will be again like that. Then you need not to do the OT LOT. Then I have to just keep the S1 pressed. Cylinder is on. If I release S1, it will be off. Fine. So if you will not use two S1 and S2, intentionally the functionality what we are trying to implement is that from one push button you will be extending and another push button you will be retracting. So what I want that I will be having two push buttons here that says extend and another push button says retract like this. And so this is S1 and this is S2. Now if you will not do that, then there's one push button only and you have to keep it pressed. You can't release it. The moment you release it, it will go off. Otherwise you can't unlatch it, because unlatch is a different instruction and I need a different input to that.
Okay.
Okay. So what we will do now, we will try to implement functionality on the first cylinder itself, the first circuit diagram here. So this is the first circuit diagram. Let's take this one. And what I want now, so I will be using only one push button here. Let's talk about this. As you are saying, so I'm defining the functionality like this, that there's only one push button and which says cycle. So when I say cycle means once you press it, what I want, my cylinder should extend and automatically return. So I need not to control the retracted motion through the manual intervention. So there are many operations in the industry. When you give some input, then the operation happens and the cylinder will go back. Maybe punching, maybe sealing. So there are many functionalities that you can implement in this way. So what we want, whenever S1 is pressed, S1 on, and you release it. So make S1 on and release, so that you pressed S1 and then released. What functionality I want, the cylinder should extend and retract, automatically retract. So to implement this functionality, what changes I shall make, now you have to advise me, whether in the electrical circuit diagram or in the ladder logic. You have to tell me how to write the program for this. Or please try it yourself, and you can show me notebook also, if you can show by making the camera on. I can see that. You can just show me that if you can attempt this. Let's take at least a pause of 1 minute. First you think yourself, because logic part you have to think. Instructions cannot themselves tell you what to write. Instructions are just in a basic programming instructions. How you will put them together for meeting a particular functionality is a kind of a logic implementation. So please do it and then we'll discuss that. So we call it an automatic return piston. Automatic return configuration. So we are just attempting this. So physically now, because we don't need a second push button, so I will be removing this second push button from here. So only I will be having one S1 here, but I will be having two solenoids certainly, because I will be attempting this on the first one. So there will be two solenoids. So one push button and two solenoids. And rest of the configuration remains same as we have seen here. So you have two solenoids, you have two proximity switches, and I will be using only one push button. Functionality I have already explained, that once you press S1 for a moment, your cylinder should go forward and then return on its own. So anybody attempted it? You can show me your circuit diagram. So Aviman, can you show that, or would you like to show your notebook? Good. So yeah, so S1, 1B1, and then you have connected 1Y1. Yeah, good. Good. I think done. Fine. Anybody else? So you have to come out with the answer. Just remain silent will not help. So whether you have understood this or not understood, I think we should decide. Anush, any?
Yes, sir.
Did you understand how to do this automatic return part?
Yes, sir. I understand. I did it with one single switch, sir.
Okay, okay, that's nice. Avinash? Avinash Kumar?
Yes, sir.
Did you understand?
Sir, actually, this is my first class, and I'm trying to get more and more out of it, and maybe
Okay, okay, fine, fine. Yeah, it's good.
Previous part also.
Fine. Vishesh?
Yes, sir.
You understand? So what should be the first rung I should draw? Please let me know.
So XIC
Yeah,
for S1
XIC instruction for S1. Then
and And OTE for 1Y1?
Don't you want to put 1B1 also XIC?
Yes, sir. 1B1 XIC and then OTE.
OTE instruction, and this is for 1Y1. Good. So this will make the cylinder extend. Now, how shall I retract that? Automatic return will happen now in this case.
So for that, we don't need to give any instruction. It is auto return piston. So when it
It's
makes
automatic return. So if you see this configuration, there's no auto return. The first configuration we are implementing. So we are implementing this for this functionality. So there's no automatic return here. So once you energize 1Y1 with the first instruction that you have mentioned, then the cylinder will remain in the extended position.
then, sir, when it comes in contact with the other end with 1B2,
Correct.
Then again we need to put XIC instruction another in another rung.
Correct. Good. So you're right. So we will be adding another XIC instruction, which will be an input to control the second solenoid.
Yes, sir.
And your second solenoid is 1/2,
1/2.
and this will be the S2.
S2.
No, this will not be S2. This will be 1B2. Sorry. We are not manually controlling it. No? We want it to be controlled by the second proximity switch. The moment cylinder reaches to the forward end position here, if you can see here, the moment cylinder reaches here, this will be on. And once this will be on, then with the help of this input, I would like to energize this so that the cylinder will go back. So this is the logic for the automatic return part. So extension I will be controlling through push button S1, but the retraction will be controlled by the proximity switch 1B2, which will be sensing the forward end position. Yes, Aman. Yes, Aman, you have raised your hand. Any doubt?
Sir.
Sir.
Yes, Aman.
Sir, can we connect in parallel with S1 XIC, 1 XIO with the 1B2 and OTU? Since S1 when false, it will become true and it will energize OTU.
Yeah, so whenever you come out with an alternate logic, let's try to draw it and evaluate actually. What you are saying, just repeat it.
Sir, this.
So I have removed this, or if you want to show, yeah, that is fine. Not getting complete sense. So you have S1 first, and then you have XIO. Just a minute, let me just draw for the class if they are able to get this. So you are adding 1B1 here.
I will draw it clearly more for you, sir.
No, you can just let me know. I will be drawing. So I will be using 1B1. Is that
yes,
okay?
Sir.
And
Yes,
then
sir.
I will be taking in a parallel branching over here, and then I will be adding an XIO instruction.
XIO. Yes,
and this
sir.
is coming from which input?
Sir, from S1 only. Energy true and false.
So then it means that see, I will be then going for the DP-DT kind of switches. It means that you have two poles actually. So right now what we are discussing, for the simplicity, each push button is having only one contact. And when you say you will also be taking, okay, sorry, you want to write in an instruction format. Fine, I got it. So let's draw it. So this is an XIO instruction coming from the S1 only.
Yes, sir.
Okay, sorry. And then where shall I connect this one? To the 1/2.
1B2, sir, 1Y2, 1B2, and then 1Y2, that is OTU.
Just a minute. So you want to connect this with the also in parallel with the 1B2, and this I would like to use it for the 1Y2.
Yes, sir.
So this is the way you are suggesting. Let's evaluate this logic that once S1 is pressed, fine, and 1B1 is true, so 1Y1 will be on.
Sir. And
because 1B2 is anyway off, so it will not be making 1Y2 on anyway. And S1 is also off, so you'll not get. So this will energize 1Y1, which will make the cylinder moving forward, and then this will go off. And then after the 1B2 will be reached, see in this case, if you see, you have released S1. Don't you?
Yes, sir.
If you released S1, this will be false.
When, sir, it will false, S1 will be true.
But it doesn't make sense. You are branching from here, na? See, if this is in series with this, if this is false, you will be getting false here. It means that this is not getting true up to this. So these are the AND, na? So you are putting this S1 and your second instruction. So in the end, if one instruction is false, then there's no meaning of the second instruction at all.
Then we have to connect it before that or for that.
So if you add this before, it's almost like a second instruction, na?
Yes, sir.
So if you are starting again from the left hand side and going to the right hand side completely parallel, it's a second rung actually. Is that right?
Yes, sir.
And in that case, why we need then S1? Because anyway, 1B2 will be detecting the forward end position. I would like to retract it. So that is what we have drawn. I need not to sense the S1 in that case like this.
Sir, S1 with XIO will not work.
No, but how you sense the cylinder is fully extended? See, unless if you are not sensing the 1B2, I don't know whether the cylinder is fully extended or not.
Yes, sir.
Please understand which input is useful where actually. That is what we want to understand here. Now what we were doing, we are doing like this. So whenever the cylinder is fully extended, we will be able to get this signal. So what is the signal we will be getting after the cylinder is extended is 1B2. And from that signal, I would be controlling the retraction part of the cylinder.
Yes.
Is that right?
Yes, sir.
So same way, that's quite possible that whenever we build the logic, we can quickly simulate in the mind and try to see that what will be the output actually, what will be the outcome for the execution of this part. So you can mentally execute it and understand that the logic part.
Okay.
Okay. Fine, I think so. I think this make it fairly clear that how to use input and output instructions so that you can build the simple logic here. Yeah, Prashasti.
Sir, if we are using 1v1 and 1v2, then it will mean that in between positions the program will not work?
No, it will work because if you see this wall that we are using in a latching wall. That is what I was mentioning, and we have taken the example of this first one only. So in this case, what happens whenever you energize 1y1 solenoid, this part of the wall. So let me just. So this part of the wall will always remain on, whether the current is there in 1y1 or not. It means that inside, because this is a electromechanical wall, there's a spool inside the wall which shift towards the left hand side. And once it shift towards the left hand side, the flow will be going into the this part of the cylinder. So it will be going this side and it will be coming out from this side. And then only if you make the current available into 1y2, then only the second part will get energized. So once you make so irrespective of what is the current on and off of 1y1, the position will not change. Once you make it on, this will remain in this position. It's like pulling something, na? So you have a solenoid at the two end and you will be having a spool inside in between. So once you energize 1y1, pull the spool towards it. And if you energize 1y2, it will pull the spool towards it. So it's a mechanical movement of the spool inside the wall that will be deciding the flow direction. So that is how it is not making a difference. So once you energize this, once you energize 1y1 for a moment, then these two inputs are not making any difference because your spool is already being shifted once this is on for a moment itself. And that will keep the cylinder moving forward continuously. You got this point?
Yes, sir.
Fine. In the interest of time, I will be stopping here. But if you still have a doubt, we can discuss in the next class. But idea is that I give two examples. We discussed 3 different type of circuit configurations. So these are the fairly good examples for understanding the basic input output instructions. So we have used